So in this tutorial, I demonstrate another way to calculate out the probabilities of the high and the low deck, given that I've drawn um, a 7 and a 7 and a 9. Um, and I set it up in exactly the same way. In this case, however, I'm going to, so this is what I'm interested in. In this case, I'm going to do it in two stages. First, I'm going to imagine drawing a 7 and then updating my knowledge. And then I'm going to draw the 9 and update my knowledge from there. So kind of as a graphic, it might look like I start off with some probability for the high deck. This would be my prior. And then I draw a 7, so then I update my beliefs given that. And then I draw a 9, and so then I update my beliefs again. So in this case, each time I'm updating my beliefs, and here I'm doing it in two stages. In the previous movie, I did it in one. I drew a 7 and a 9 and did the calculation all together. So in this one, I'm going to do something a little bit different. So let's go through how you do this. So the first step is to update our knowledge, given we start with a prior and then we go to an updated belief. So we write Bayes' theorem as following Bayes' recipe. We write out the top, we have the likelihood term, and then we have the prior. And we do the same thing for the low deck, given the likelihood given the low deck, and then the prior for the low deck. Okay, so this is 7 out of 55 for the likelihood of getting a 7, knowing I have the high deck, and then I have the 1/2 prior like I had in the previous one. I have 4 out of 55 times 0.5 for the prior for the low deck, and this translates to 0.64. Actually, it translates to 0.064. Sorry, and then this one's 0.036. Those are the results of putting this through the calculator. I then add up all these possibilities. I get a k is equal to 0.1. And then I go back and I redivide. So then I have probability of the high deck given the 7 is equal to 0.064 divided by the k, or 0.1, and this gives me a 0.64. The low deck given just the 7, 0.036 over the k, 0.1, and then this is 0.36. Okay, so I have 64%, 36%. Drawing the 7, this gives me the first step of my updating knowledge. So this part of it is the middle part. Okay, now I'm going to draw a 9. Okay, so let me summarize over here. So I have probability of the high deck given that I just drew the 7. I had that at 64.64. Probability of the low deck given I drew a 7 at 0.36. And now I'm interested in the high deck given that I drew a 7 and a 9. And the same thing for the low deck. Okay, so what we have is Bayes' theorem, but we're treating the 7 as known knowledge from before. That was what our state of knowledge was. So then the form looks a little bit different. So actually we're going to do the proportional. So we're only going to do the top part. So we have the likelihood term, but it looks like this because we know that we drew a 7. And then we have the new prior term. Again, on the right-hand side, the 7 is appearing because we know that already from our previous state. 9 given the low deck and the 7. Probability of the low deck given the 7. Now these numbers, which are our priors, are really the posterior from a previous calculation. So what's happening is Bayes' theorem is really a statement of learning. We start off with some base knowledge with our prior, we take some data, we update our beliefs, and then those beliefs form the prior for the next time. So it's this iterative process. Okay. So what then we can set this equal to, we have 9 out of 54 times 0.64, and we have 2 out of 54 times 0.36. We add these up to get the value of k, and the value of the high deck term is 0.107, and the value of the low deck term is 0.013. So this one is 107. This is 0.013. We add them up. We get a value of 0.12 for k. Now we go back and we do the equal sign. 0.107 divided by the k, 0.12, and this gives me 0.89. Probability of the low given 7 and a 9 equals 0.013 over the 0.12. This gives me a 0.11, and these are the final things. Now, you may notice that these are slightly different than the result I got in the previous movie. In the previous movie, I rounded out one too few decimal places, and so I ended up rounding out a little bit. If you go back to the first movie, the previous one, you will find that if you calculate out the values out one more decimal place, that you will in fact get 89 and 11%, as opposed to 88 and 12. And this is the rounding error. You actually get, and you can demonstrate it mathematically, identical results this way. What we have then is essentially kind of a reconfirmation that equivalent states of knowledge have to yield equivalent probability assignments. So that is kind of a key point. So if you collect the data all at once, 7 and 9, and we update our beliefs, we get the same as if we updated iteratively, drawing the 7 and then updating, and then drawing the 9 and updating. And and they give you equivalent points. So Bayes' theorem can be used in this kind of learning mode, where we use the posterior from one calculation as the prior for the next. And so you can always think pretty much that any prior you use is really the posterior of kind of your previous experience. And that's how it can be done.